My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 170. Please turn to page number 170, problem number 131. The penultimate problem, second to the last problem. It says, 131, it says David has D books, which is 3 times as many as Jeff's, and it should say 3 times as many as Jeff. It should say 3 times as many as Jeff's with apostrophe S. What the hell is the problem? Which is 3 times as many as Jeff. David has D books, which is 3 times as many as Jeff. The books are not 3 times as many as Jeff. They're 3 times as many as Jeff's with the apostrophe S. It's missing there. And half as many as Paula's, or half as many as Paula has. What the hell? And half as many as Paula's. The question simply is, how many do all 3 have in total? I want to think about it for a second here. I want to make sure that I do not make a fool of myself. I have twice as many books as you? No, I do not have twice as many books as you. I have twice as many books as you do. Or I have twice as many, Jeff has twice as many books as Mike does. Or the number of books that Jeff has, David has D books, David has D books, so we're comparing D books, you see? We're comparing D books. David has D books, which is 3 times as many as Jeff. No, Jeff's with the apostrophe S. I'm quite certain about it. I may be wrong, but I'm fairly certain about it. And half as many as Paula's. Anyway, enough of that. There are 2 ways we can solve this problem. There are 2 ways we can go about it. One is what I call the classical way, the traditional way, the orthodox way, the geeky way, the nerdy way, the academic way, the algebraic way, the proper way. The other one is what we call the non-traditional way, the quick and dirty way. In the quick and dirty way, what you do is you plug in numbers for these variables and thereby convert this algebra problem into an arithmetic problem. Let's do that way first, okay? Now when you're plugging in numbers, it's always a good idea to identify where does this story build from, what is the foundation of it. You don't want to build from the top down, you want to build it from the bottom up. Okay, you don't want to start the top floor and start building all the lower floors. You want to start from the foundation and then go from there. Let's find out, where does the story begin. Does the story begin with David? No. David has D book, which depends on how many this guy has. And this guy, how many books Jeff has, depends on how many David says. Oh, actually it does begin with him. This guy has 3 times as many as Jeff's. Okay, David has D books, which has 3 times as many as Jeff. So Jeff is the point of reference. Jeff is the point of reference. Let's pretend that Jeff has 100 books. Let's pretend Jeff has 100 books. In other words, J equals 100. David has D books, which is 3 times as many as Jeff's. So if Jeff has 100, David must have 300. David must have 300. Because 300 is 3 times as many as Jeff's book. And half as many as Paula. For David, we already know that has 300 books, and they're telling us that's half as many as Paula does. Paula must have 600. Paula must have 600. The question simply is, how many total books they have altogether? Well, the answer is 1000. The answer is 1000. This is what I call our punchline. I'm not sure if punchline is hyphenated or not. Punchline cannot be two words. It's probably one word. I'm not sure if it's hyphenated or not. But anyway, what I'm trying to say here is the punchline. That's our punchline. What we have to do now is go through our answer choices. Wherever we see D, we replace it with 300. Wherever we see J, we're going to replace it with 100. Wherever we see letter P, we're going to replace it with 600 until we hit upon an answer choice that gives us our punchline, which is 1000. Let's go through them. Answer choice A says 5/6 times D. 5/6 times 1000. 5/6 times 1000. Oh, sorry, D is not 1000. I'm not paying attention. I'm not paying attention at all. 5/6 times D, which is 300. 6 divided by 300 is 50. 50 times 5 is not 1000. B says 7/3 times D. 7/3 times 300. 300 divided by 3 is 100. 100 times 7 is not 1000. C says 10/3 D, which is same as 10/3 times 300. And 300 divided by 3 is 100, and 100 times 10 is your 1000. There you go, that's our answer. Answer is C. If you try out D and E, you'll see that D and E do not work. We were looking for 1000, we found 1000. If you want to try it out on your own out of curiosity, you will see that D and E do not work. So this was one way of doing the problem. Another way to do the exact same problem is to do it in a more classical way, more traditional way, more orthodox way, which is the algebraic way. Let's do the algebraic way now. And the algebraic way is very straightforward. This is the more traditional way. This is the way your math teacher will do it. David, we are told, has 3 times as many books as Jeff. So that's 3 times J. And we're also told that the amount of book that David has is half as many as Paula. Half as many as Paula. So it also equals half as many as P. That's it. That's all we need. And the question is, what is the total number of books? The total number of books is D plus J plus P. D plus J, which we know, J now we know is D/3. If Jeff has, which is 3 times as many as Jeff's book. If David has 3 times as many books as Jeff does, then Jeff must have 1/3 as many books as Dave does. That's all. So it's D/3 plus P. David has half as many books as Paula does, so Paula must have twice as many books. P equals, from here, P equals 2 times D. We put it in here. And then we find our common denominator. The common denominator is 3, so this becomes 3D, this remains D, and this becomes 6D. 3D plus D plus 6D is your 10D over 3, which is what we found the answer to be. So that was more of a classical way of doing it. That's it, we're done with this one. 132, where is 132? 132 is the very last problem on that page. Let's get it out of the way so that we're done with this page. In 132, we're given a list number 1, which is 3, 6, 8, and 19. In list number 2, we are given X, 3, 6, 8, and 19. In other words, all the entries in list 2 are the same as before, except we have one number which doesn't exist in list 2 or list 1. We are told that the median of list 1 equals the median of list 2. So let's call this median of list 1, let's call it M subscript 1 equals M subscript 2. The question simply is, what is that X? The list 1 here, let's call it L with subscript 1, is, list 1 is 3, 6, 8, and 19. since it only has 4 entries, since this has even number of numbers, the median is not going to be the one number right in the middle. The median is going to be the average of the two numbers in the middle. The two numbers in the middle are 6 and 8. Their average is 7. That's their median. So m with subscript 1 is 7. That's their median. I should have stuck it like this. The median is 7. In the list 2, we have 3, 6. Now since median of first series is same as the median of second guy, since they both have the same median, and we do not see any 7 in this guy. We see a 3, we see a 6, we see a 8, we see a 19. There is no 7 in there. There is no 7 in there. And we have this guy x, which means x must be the 7. So here we have 3, 6, 7, 8, and 19. That's the only way we're going to make the median to be 7 and still have our x in it. The x was the missing one. That x was right in the middle here, and then we have our 8 and 19, and that x is the 7. So the missing number is 7. What's the value of x? The answer is 7. The answer is letter B. That's it. We are done with this page. I'll see you tomorrow. Okay? Bye now.